Hey everybody, Mr. Smith here. Great to see you. In today's slide deck, what we're going to do is to dive right in and give you the basic 3 skills you need to do to be able to use trigonometry in class. So first things first, you might remember that in the trig of right triangles, there are some words. There's the adjacent, the opposite, the hypotenuse, and we're going to start with the Pythagorean Theorem, which you probably remember says c squared equals a squared plus b squared for right triangles. A quick review. The hypotenuse, here's how you spell it, Hypoteneus. It's not just any old side you feel like making it be. The hypotenuse is always side C in your formula and the longest part of the triangle, the one that's opposite the 90-degree angle. Okay, that's really important. So the first thing we're going to do is remember that when I'm trying to solve for this unknown side down here, side B, I have to set this Pythagorean theorem up the right way. So C is going to be 8 in this picture equals 5 squared plus b squared, and the rest of it should take care of itself. So I do the squaring, I get 64 equals 25 plus b squared. Do a little subtracting, subtract 25 from both sides, and you get 39 equals b squared. Square root both sides, and when you go ahead and solve for this thing, the square root of 39 is like 6.25 when we plug it into the calculator. Okay, so what's the takeaway there? The hypotenuse of the triangle is the side that's opposite the right angle. But there's 2 other sides that are important. So you may have remembered from Trig this acronym called Sohcahtoa, and it's the most popular way to understand trig by far when you teach it in math class. What these things stand for is the sine of an angle. Let's call it the sine of this angle down here is called theta, is going to equal the opposite over the hypotenuse. So that's what the SOH stands for. Sine equals opposite over hypotenuse. Thing 2, cosine equals adjacent over hypotenuse. So we could write cosine of theta equals adjacent over hypotenuse. And then finally, tangent equals opposite over adjacent. So tangent of theta equals opposite over adjacent. Now, the big thing that I want you to know as you look at trigonometry is that trig is really useful. You can use it for exactly 2 things. You can use it to figure out an angle that you don't know. The other thing you can use is if you do know the angle and you don't know either the opposite or the hypotenuse, you can use it to find one of those. So it's kind of like all the math things we do. There's 3 things in this formula. There's an angle and there's 2 sides of a triangle. And if you know 2 of them, you can always figure out the 3rd one. So the big thing that you need to be clear on that I think makes trig kind of confusing for some guys is you need to get clear about what parts of the triangle are what. So because I'm a physics teacher, I always think about my situations as though they're real physics. So I'm just going to draw a little cartoon guy. This is me. I'm standing opposite angle theta, or right next to angle theta, and the opposite side of the triangle is that one. So if I go and write sine of theta, it's really a fraction. Sine of theta equals the opposite. That's 5. Divided by the hypotenuse, that's 8. So if all I knew was the 5 and the 8, I could still use these trig functions to figure out the sine of theta. And so we'll do that in a second. But let's go ahead and write down the other fractions. Just a second ago on the last slide, we figured out that this side right down here, side B, was 6.25. We used Pythagorean Theorem to figure it out. So if I wanted to write cosine of theta, that equals adjacent over hypotenuse, it's just a fraction. It's 6.25 over 8. And in the same exact way, if I wanted to do opposite over adjacent, that would be 5 over 6.25, and that would give me the tangent of theta. The big thing to know is that I'm standing at angle theta, and that's what makes this the opposite. Okay? So if I stood up here, the opposite would be this guy, and it would flip. Totally okay, as long as you know what you're doing. So what I want to do is actually go to the next slide and grab my calculator and really work these things through. But I'm going to do, first of all, one little presto changeo on the notation. So just a second ago, we wrote sine of theta equals 5 over 8. What I want to show you how to do is write this, this function so I can get the theta. There's a thing called the inverse trig function. So basically you think about sine of theta equals 5 over 8. It's like this is the answer, and this is the thing that it's supposed to work on. So theta itself in math you write as the inverse sine of 5 over 8. You basically think of it as like an undo button for the sine function, okay? So you could do the same exact thing with the other trig functions, but what I'm going to do is to grab my calculator right now, and I'll show you how that looks. Okay, so in the Casio, what we're going to do is to first of all check and see what mode our calculator's in. So if you see, I've got a shift button up here at the upper left, and I've got a menu button right there. So if I combine the two, I get what's called the setup mode. So shift and menu gives me setup. And your calculator might be in this mode right here called radian mode. It's great for math class. It's a natural for there, but physics, like a lot of real world subjects, works in degrees, and so we're going to pick this F1 button and now change it to DEG. So everything I'm going to do now will work. I'm going to hit the exit button, and what I want you to notice is you have sine, cosine, and tangent down here. So these are where we live when we're doing trig functions. And also, if I hit the shift key again, you'll see that the orange or the yellow above those says inverse sine, inverse cosine, and so on. So the thing I was just about to do was to plug in inverse sine, so sine to the minus 1, open up my parentheses, and then type 5 divided by 8, close those parentheses, and hit EXE, and there you go. The answer that I get, 36.68 degrees, okay? So I think a big thing with trigonometry is not to get too hung up on the perfect way of doing things. There's a lot of ways to solve these things. And if you find a way that always works for you, then go ahead and do it. You might want to use Pythagorean Theorem first to find this one, and then use your favorite trig function. That's all good. What I'm going to do is show you the fastest way to do this one. And what I'm going to do is, because we're talking about this angle theta and we want to know it, I'm going to park myself right here and do the thing I talked about before. If I'm standing on angle theta and I throw a rock, that hits side B. So I know that side B is the opposite. So what that makes me realize is then the two sides of the triangle that I'm given are this one and this one. So this one is the long one. It's opposite the 90. That's going to be the hypotenuse. This one right here is not the opposite. It's not the hypotenuse. It's got to be the adjacent. So what it lets me do is to go shopping, and I think about which trig function involves the adjacent and the hypotenuse, and what I come up with is cosine. So you'll see me write out cosine of angle theta equals adjacent over hypotenuse, and that equals 125 over 295. And what I'm going to do is just write it out in symbol notation. So theta equals cos to the minus 1 of 125 over 295. And I'll show you in a second how I do that in a calculator. But what I'm going to get is 64.93, or just about 65 degrees, okay? So let's check that out and see how it looks in the calc. Okay, so in this case what I've got is inverse cosine, so I hit shift and then cosine, pulls that up. Remember to hit your parentheses, and now I just type in 125, not 135, 125, divided by 295, and remember to close those parentheses. And I've already got this guy in degree mode, so that's where I get my answer from, 64.93, just like we promised, okay? So that's how you find an angle on the trig function. I call it using the trig function backwards to make you give up the angle. What we're going to do is show you the other thing you can do, which is use the trig function going forwards, where they give you the angle, and you can solve for one of the sides of the triangle. So let's go check that out. Okay, so for this one, what we've got is a hypotenuse. Hypotenuse is 62. And they're asking us to solve for this side, x, and in fact, they're asking us to solve for all the sides of the triangle, which is pretty common. We do that a lot when we're getting rolling, just for practice. So as usual, what I do is I park myself near the angle that I'm interested in, and then I throw a rock, and the thing that I hit is the opposite. So in this case, I know that x is actually the opposite. They gave us the angle this time though, right? So like we said, we used the trig function a minute ago, going backwards to find the angle. What I'm going to do is to think of a trig function that involves the opposite and the hypotenuse. So I'm thinking of sine, and I'm going to write down the trig function and plug in everything I know, and then solve from there. Okay, so how do we do that? Let's go and write down sine of the angle. So this is going to be sine of 25 degrees. So it's not an unknown anymore. It's actually a number we know. So equals opposite. We can leave it as opposite over hypotenuse equals 62. And then, so the algebra here is real easy. We have opposite over 62, just like all of our fraction things. You can make it not a fraction by multiplying both sides by the denominator. So denominator comes up, and I get 62 times the sine of 25 degrees, and that's going to equal the thing that I'm after. Okay, so let's go show you on the calculator how that looks. Works exactly like what we just said. Okay, so what we said is we're going to type in 62 times, now it turns out with the Casio you don't even have to write the time symbol, you can just do sine of 25, and since the calculator is already in degree mode, it understands the way to do that, and it coughs that right up for us, and so we get what, 26.2. Okay, so let's take it out. Okay, so to finish this example off, we're going to take what we just learned, which is that this piece over here is 26.2, and we're going to figure out absolutely everything else. The thing with right triangles is there's just a couple basic facts about them. All the angles of all triangles add up to equal 180. So one of the automatic things you can easily do if you know this angle, and this is always going to be 90, is you just add them together and you say 180 degrees minus, and these are going to add 90 and 25 equal 115. So you can subtract those two things and get 65 degrees. That's going to be our mystery angle up here. Solved. Done. The other piece down here, though, is the adjacent. So when we were standing right here, we said that the 26.2, the x, was the opposite. So what we can do is use Pythagorean Theorem. And remember, the hypotenuse here is going to be 62. So we can just write that equation out. 62 squared equals 26.2 squared plus adjacent squared. And when we solve for all that, we're going to go and get the adjacent equals 56.2. Okay, so on your own calculator, I want you to go ahead and prove that to yourself, see if that works out. But those are enough basics. Trig functions going forward, trig functions going backwards, and Pythagorean theorem. That's enough to get us going on the first thing we're going to do tomorrow, which is lab. So take care, and I'll see you real soon. Bye-bye now.